Okay, guys, let's go ahead and go over these are the homework problems I gave for solving rational equations. I had a couple questions on them. So let's make sure we're comfortable on what to do here. So with number one, again, since it's an equation, the idea is you want to get rid of these denominators because you don't want to deal with fractions in your problem. So you're looking at v squared, v, and v, and you want to think about if you could multiply this entire equation by one thing, what is the one thing that would cancel all of those? And what I saw a lot of people were doing, they were multiplying the entire problem by v, okay? And if you multiply the entire equation by v, let me just start that. That's not the correct thing you want to do, but if you did, okay, here's what would happen. If we multiplied by v, when you go to multiply by this v plus 4, it would be v times v plus 4 over v squared. Okay, and then when you multiply that, it would become v over v. And when you multiply the v over here, it would become 3v over v. And this is what a lot of people did. And then they actually distributed this v times that v and got v squared, and then somehow canceled the v squared in the denominator. Okay, something like v squared plus 4v. I saw a couple people do this, and they canceled the v squareds here. Okay, you cannot do that. That doesn't work. The reason it doesn't work is because the numerator is, as written here, is v squared plus 4v, right? So that's really the same as 4v plus v squared. And what you're saying is that if you have 4v and you add v squared to it, and then divide by v squared, you're saying the dividing by v squared cancels out the adding v squared, right? So canceling that. That is not correct, okay? So that doesn't work. The dividing will only cancel multiplication, okay? So that's why that one won't work that way. What you need to do, let's see if I can erase all this. You need to actually multiply by the least common multiple of those denominators. Okay, so we need to be multiplying here by v squared, not just v. Okay, because as we showed, v was not big enough, basically, to get everything canceled out. Oops, I had something hidden there. I had problem 3. I'll just leave it for now. Okay, so let's just check out what happens if you do this correctly. If you multiply by v squared, okay, watch what happens. You have v squared times v plus 4 over v squared. Now in this case, the next step, those v squareds will cancel because the v squared is being multiplied by something. Okay, and even in the other problems, the other terms I should say, the denominators are still going to get canceled out. Okay, so I went ahead and erased number 3 to give us some room. But here's what's going to happen now. So again, we distributed v squared to everything. Oops, I need this to be black. Let's just go with red. V squared gets multiplied there, there, and there. Okay, with the 1 in the denominator. Now we can do our canceling. V squared cancels with v squared because it's v squared times something up here. So dividing by v squared would undo that. So this is just left with v plus 4. Okay, here v squared divided by v, you can think of v squared as v times v. So one of the v's cancels. You're left with just v. And then same thing up here, 3v squared is 3 times v. So one of those v's would cancel, and you would just be left with 3v. Oops, I accidentally put a equal sign where I should have put a plus sign over here the first time. The joys of working on an iPad. Sorry, this is a plus here. All right, so we have v plus 4 plus v equals 3v. Okay, so it looks like combining the like terms on the left, we have v plus v is 2v plus 4 equals 3v. And then from there, we could just subtract 2v from both sides and get 4 equals v. Okay, and there's no restricted value there, or that one's not a restricted value, I should say. The only restrictions are what make these denominators 0, so v cannot equal 0. So our answer of 4 is good to go. Okay, so moving on to number 2. Again, what I'm doing, I'm taking a look at those denominators first. They're both v plus 5. So in this case, it's pretty straightforward that the thing we need to multiply by, the thing we want to cancel, is just v plus 5. Okay, so if we multiply every term by v plus 5, that 1, when I distribute v plus 5 times 1, it's just v plus 5. Okay, v plus 5 times 1, it was over v plus 5. Okay, and I can see we're going to run out of room. Let's see if we can do some moving here. There we go. And multiplying this term by v plus 5 is going to be 5 times v plus 5 over v plus 5. Okay, and this is the point where you need some things to start canceling out for you. Okay, that first term, that v plus 5, there's no denominator in, but the middle term, v plus 5 over itself, is going to cancel out. Now, that does not just disappear. It's something divided by itself. It needs to become a 1. Okay, and on the other side of the equation, the v plus 5's cancel. So we are left with just 5. Okay, so I saw a couple people who had asked questions they missed. They just canceled this out, and they didn't put the 1 in its place, and they just said v plus 5 equals 5. But it really needs to be v plus 6 equals 5. So when we subtract 6 from both sides, we get our answer of -1, and that works because the only restriction would be that v cannot be -5. Okay, so -1 is totally good. First one, because that kind of shows a good example. You know, what is it that you are, what would the common denominator have been? Okay, it's another way to think about when you're trying to figure out what to multiply by. What would the common denominator number 1 have been? So if one of the terms had v squared and the other ones just had v, you would need to use v squared as the common denominator. Okay, so hopefully that helps. And again, feel free to email me with any questions. Okay, and last one here, we do need to do a little bit of factoring. That middle denominator looks factorable into, what do we got? We need to add up to 10, I'm sorry, multiply to be positive 10, but add up to -7, so r minus 5 times r minus 2. Okay, so if we look at the denominators now, I know I need an r minus 5 canceled. We already said r minus 5, then we need to multiply by r minus 2 as well, and then that's just a repeat. So we're going to need to multiply this by r minus 5 and r minus 2. Okay, and you can kind of check, make sure what you're multiplying by is going to be enough to cancel each of these out. So is r minus 5 going to get canceled? Yep, sure is right there. Are both of these going to get canceled out? Yep, we got both. That's exactly what we're multiplying by. And is r minus 5 going to get canceled out? It's right here again, so yes. Okay, so let's multiply the whole thing. Okay, and I'm just going to write it all out before I do any canceling. So when we distribute this thing to the 3, it will be 3 times r minus 5 times r minus 2, and it's all over r minus 5. Okay, remember the denominators aren't changing. Then the middle term, it's just getting multiplied by 1, so it's going to be r minus 5 times r minus 2 over r minus 5 times r minus 2. And then the other side of the equal sign, the numerator is just 1, so it's just going to stay as r minus 5, r minus 2, and its denominator was r minus 5. Okay, so we carefully did our distributing. Now we're ready to cancel out, get rid of all these fractions, get yourself an easier equation. Okay, we're left with 3 times r minus 2 plus, okay, here's another one where everything cancels. It's going to turn into a 1. And the other side, we're just left with an r minus 2. Okay, so we should be able to solve this guy out now. 3r minus 6 plus 1 equals r minus 2. So 3r minus 5 equals r minus 2. Subtract r from both sides. Add the 5 over, and then divide by 2. Okay, and that should work again. Our only restrictions from the original denominators were r cannot be 5, r cannot be 2. So our 3/2 looks good to go. So that's the process on those. Just kind of go back and take a look and think about, even going back